Cloud seeding is undertaken by dispersing substances into the air that serve as cloud condensation or ice nuclei. Common agents include silver iodide, potassium iodide, and dry ice, with hygroscopic materials like table salt gaining popularity due to their ability to attract moisture. Techniques vary from static seeding, which encourages ice particle formation in supercooled clouds to increase precipitation, to dynamic seeding, designed to enhance convective cloud development through the release of latent heat. Methods of dispersion include aircraft and ground-based generators, with newer approaches involving drones delivering electric charges to stimulate rainfall, or infrared laser pulses aimed at inducing particle formation. Despite decades of research and application, cloud seeding's effectiveness remains a subject of debate among scientists, with studies offering mixed results on its impact on precipitation enhancement. Some studies suggest it is difficult to show clearly that cloud seeding has a very large effect. Environmental and health impacts are considered minimal due to the low concentrations of substances used, but concerns persist over the potential accumulation of seeding agents in sensitive ecosystems. The practice has a long history, with initial experiments dating back to the 1940s, and has been used for various purposes, including agricultural benefits, water supply augmentation, and event planning. Legal frameworks primarily focus on prohibiting the military or hostile use of weather modification techniques, leaving the ownership and regulation of cloud seeding activities to national discretion. Despite skepticism and debate over its efficacy and environmental impact, cloud seeding continues to be explored and applied in regions worldwide as a tool for weather modification. The most common chemicals used for cloud seeding include silver iodide, potassium iodide, and dry ice solid carbon dioxide. Liquid propane, which expands into a gas, has also been used. It can produce ice crystals at higher temperatures than silver iodide. After promising research, the use of hygroscopic materials, such as table salt, is becoming more popular. When cloud seeding, increased snowfall takes place when temperatures within the clouds are between 20 and 7 degrees Celsius. Freezing nucleation is induced by the introduction of substances similar to silver iodide, which has a crystalline structure like ice. In mid-altitude clouds, the usual seeding strategy has been based on the fact that the equilibrium vapor pressure is lower over ice than over water. The formation of ice particles in supercooled clouds allows those particles to grow at the expense of liquid droplets. If sufficient growth takes place, the particles become heavy enough to fall as precipitation from clouds that otherwise would produce no precipitation. This process is known as static seeding of warm season.